Hello world, we have another pretty cool interview problem today. So today our problem, as you might have guessed by the title, is to reverse a linked list. So this is a singly linked list and we are going to be past the head of the list, and the idea is that we want to reverse it and then be returned a pointer to the new head. So the rest of the file down here, we just have a main function. It gives us a list of the numbers 1 through 10, and it prints it, and then it prints the reversed version of it. So the issue here is our method currently doesn't do anything. It just returns a head again, so it just prints the same exact list twice. So let's change this to get this to print it in reverse. So if you haven't thought very much about this problem, or you want some time to think about it before we get to the solution, you should probably go ahead and pause now because we are about to get started. And it is too late to pause. So let's go. So when you think about reversing a linked list, you're not creating any new nodes, right? All the same nodes are still going to be in the list. The only thing is that now they are going to be pointing all in the reverse order, and we're going to have a new head. The head is going to be what would have been called the tail on the previous list, and vice versa. So let's take a look at what that means exactly. So if we want to reverse a linked list, we need to, at each individual pointer, change the direction that it's pointing in. So instead of pointing from 1 to 2, it has to point from 2 to 1. Instead of pointing from 2 to 3, it points from 3 to 2. And you'll see that if we do that for all of the pointers, we will actually end up with a perfectly reversed linked list. There are edge cases at the beginning and the end, which we will have to make sure to handle, but that is the general idea. So the good basic approach to this is to iterate through the list, taking a pair of nodes at a time. So first we'll iterate on looking at nodes 1 and 2 and reverse that pointer, and then 2 and 3 and reverse that pointer, and then 3 and 4 and reverse that pointer, and so on and so forth. So since we're going to be working on pairs, what we are going to have to start by doing is checking to see if either the first node is null or if the second node is null. And if either of those cases are true, we don't actually have to do anything. And the reason we don't have to do anything is because, well, if the first node is null, then it's an empty list, and you can't reverse an empty list because there's nothing in it to change. And if the second node is null, so if node.next is null, then that means that the list only has one element. So again, there's nothing to reverse. Um, the head stays the same, and it still points to null. So in either of these cases, we can just go ahead and return the node that we were given. Now is the more interesting case. Before we move on, you might know that in some programming languages, the OR symbol, the way that it works is that if the first expression evaluates to true, then we don't even touch the second expression, because true or anything else is always true. So in order to save time processing, and it's part of the language design at this point, it's so common, we don't actually process the second expression if the first comes out to true in an OR, and with ANDs it's the same except with a false. And that's actually really useful here because now we don't actually have to do any sort of check here, because if node is null and we call node.next, that would be a null reference exception, that would be bad, that would break the world. But we know that node will never be null here, because if node ends up being null, this will resolve to true, and we will immediately return node. We wouldn't even compute the second expression. So that's something that's kind of common knowledge, but if it's not, then it can end up causing a lot of really ugly bugs. All right, enough delaying. Let's get into the fun part. So we are going to be iterating through the list 2 nodes at a time. So the node that we are past is the head of the list. So we can go ahead and call that head just to make life a little bit easier. So now let's get to actually implementing this. So we are going to be going 2 nodes at a time. So our first node is going to be current, and we can call our node after current, well, we want to set current to head, and we can call the node that comes after current next, and that will equal head.next, neither of which are null. And we know that because of this condition up here. So we have a bit of a special case with the first and last elements of the list, because the first element pointer will now have to point to null because it's becoming the tail, it's the end of the list. So that we actually want to do before we even go into any sort of loop or anything. We can say current dot next equals null. And it's very important that we actually get the pointer to next right here before setting it to null, because if we set this to null first, we would have lost track of the pointer to the second element, and therefore we would have lost track to every other element in the list. And then we would be in a lot of trouble. But if we take the value of head.next and set it to next, and we set this to null here, that means that we are ready to go into our loop. This is just our setup step right here. We're setting our 2 variables that we're going to use to iterate, and we are handling this edge case here with the first element. So now let's step into our loop. Now let's think about how long we're going to iterate. So we want to iterate as long as you normally iterate with a linked list. If you want to get to the end, you iterate until, or you iterate by saying while current is not null. But in this case, next is going to be ahead of current by 1 at all times. So what we are actually going to say is while next is not null. So because current and next are always going to be one right after the other, that means that when we exit the list will be as soon as next has passed the last element. And that means the current is actually pointing straight to the last element because next is one past it. So we are actually just going to return current. And I know there's still lots of stuff that has to go in the list, but the general idea is we're going to be iterating through the list in one element at a time, but each time we're going to process 2 elements and the pointer between them. So now let's look at what actually goes in the loop. This is the interesting part. So what we want to do is we want to make next point to current. So we want to make next point to current. So it might be, you might want to say something like next dot, this is a bad variable name. Why did you let me do this? Next, so you might want to say something like next dot next equals current. Oh, this is so ugly. If it weren't for syntax highlighting, I would scream at myself right now. But, all right, we'll let it go. So we are setting next dot next to current. So we're making it so that if we're just looking at this linked list down here with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right now what we would be doing is we would be setting 2 to point to 1. And that's good. We're reversing the way that it's pointing. But there is one big problem which you might notice, and that is, how do we get to 3? Where is 3? Well, 3 was what next.next was pointing to, but we lost track of it. So we actually have to up here store what next is pointing to before we even do anything else. So we can give it some really awful name like next. because we're already too far in with awful names. So we can have next point to next dot next. Oh, this is so ugly. Be careful when you name your variables so you don't end up in situations like this. So, so in this situation, with our first iteration, current is pointing at our 1, next is pointing to 2, and next is pointing to 3. So then when we say next equals current, we're saying 2, we want number 2 to point to number 1. We want number 2's next element to be number 1. So that's what we're doing right here. And then after this, we just have to update the pointers, or we're actually done updating the pointers in the list here. Now all we have to do is just iterate forward to the next, for the next iteration, so that current and next are both pointing to the right values. So we can just say current equals next, because actually, can we do that? Yeah, we can, because current is still, yeah, we're still good, because next is this is what happens when you name variables next. So next is not actually the dot next right now for anything, but it's called next because I am bad at naming things. So we have current equals next. So right now, if we're looking at that situation, we have where current is 1, next is 2, and next is 3. Now here we're saying current becomes 2, next will become 3, and 3 is next. Oh, at least we used camel case. And 3 becomes next. So let's think about the situation that we're in right now. Right now what we did was we made it so that, looking at our 1, 2, 3, just looking at the beginning of the list, we made it so that next, so 2 dot next equals current, which is 1. So we made it so that 2 points to 1, and here current was 1, next was 2. So we swapped the order that they appear in the list, and then we iterated by moving current up to 2 and next up to 3. So now on our next iteration of the loop, we're going to take 2 and 3, and we're going to swap the order of them in the list. We're going to make 3 point to 2, and 2 is already pointing to 1. So after this iteration, we have the list reversed starting from 3. So then we have 3, 2, 1. And this will continue all the way until we get to where next is null. So when next is null, that will mean the current is pointing at 10. And of course, 10 is our last element, which has just become our first element in the newly reversed list. So we are going to go ahead and return that. So this seems like it should work. Let's run it and see. There we go. So now you can see that the list starts at 10 and it ends at 1. So again, there are a couple interesting parts to this problem that are easy to forget. First one is we want to make sure that head.next and head are both not null at the beginning, because you can get some exceptions at this step. Because while you could claim it's invalid for a linked list to have null passed in its head, you can't really make a good case that having a single element list is invalid. That is a list. So we want to make sure we handle that case. Second thing to make sure of is that you remember to set current.next to null. If you forget this step, things don't look good. Then we end up with this, and it's still going. It is still going. We end up with the first element pointing to the second and the second pointing to the first. Remember, our old first element should become the last element, so it should point to null. Last thing to keep in mind is before you set the next element, the one that's ahead of current, before you set that to point to current, make sure you store its following value somewhere else, because we're going to need that when we iterate forward. Other than that, it's a pretty straightforward problem. It is good to know. an interesting follow-up to think about would be, how would you do this if you weren't allowed to modify the original list? So in this case, we were allowed to modify the original list. We did, in fact. If you tried to use this linked list later on, all the nodes would be pointing the wrong way, and we basically invalidated the old linked list. So that would be an interesting question to think about. We're not going to go into that now, but it's always good to think of what a follow-up question might be, or really just to think about weird edge cases or different constraints you can always attach to a problem to make it a little bit trickier. But until then, I hope that this has been helpful, and see you all later.